Hello and welcome to Kerbal space program. We are orbiting the moon and we are at some very high altitude, so we are in realistic Kerbal space program. Today we are going to test some things, especially gravity and gravity assisted re-entry into Kerbal atmosphere. As we know, if we fly by in front of the planet, we will decrease our velocity, and if we fly by behind the planet, we will increase our velocity. So, let's see how it affects our re-entries. The first thing we are going to try is we are going to re-enter with periapsis right behind the Kerbal, apparently giving us the speed boost. Let's try it out. We are going to perform 4 tests. The one is with periapsis behind the Kerbal, one is with periapsis in front of Kerbal, one to the periapsis to the left side and to the right side. So the re-entry point is behind and in front of Kerbal for those 2 tests. We're going for very generous periapsis of 65 kilometers, and here we go with our first re-entry. We are approximately at 80 kilometers when we start getting re-entry heat effects, and we are piling up the G's up to 2.5, 3, and our periapsis is actually falling in front of us, but that's okay because our G meter is actually going down. So we are decelerating at approximately 2 Gs and falling, and coasting at approximately 63,000 meters. So let's see what happens next. We still have approximately 8 kilometers to bleed off. Sorry, 6.5 kilometers. Our apoapsis is already inside the planet because we are lower than orbital velocity. That means that we are going down in any case, regardless of Jebediah survival. So let's see what is going to happen. We are piling up the G's again, and we reached almost 8 Gs before the G meter goes down, and we see that the re-entry was successful with no issues. So let's go to the test number 2. In the second test, we're going to pass in front of the Kerbal. That means that we will get our velocity lowered. So let's see how it goes. Let's fine-tune our maneuver node, make sure that everything is perfect, and let's execute it. Getting the same periapsis of 65 kilometers, fine-tuning it in the last burn, and let's time warp to Kerbal. Unfortunately, it is going to be a night re-entry, but all we need to know is on the Kerbal Space Engineer, and it is not affected by the light. So we are re-entering the atmosphere, and immediately we start in piling up the G's up to 2.5, 3 G's, 3.5, 3.4 G's, and we are starting to bleed off our speed, and the G's actually fall down. I would assume that this is the effect of the gravity assist we are getting from Kerbal, because your Kerbal is also slowing us down. We are getting additional 1 G of deceleration on the actual re-entry. And at some point our G's stop falling. We start piling up the G's again. Our apoapsis is within the planet, and that means that Jebediah Kerbal is going down no matter what. So let's see how that goes. We are coasting at 55 kilometers this time, 52, So our periapsis is lower this time, and we got to 8 Gs, and at 8.2 our G counter starts going down and everything is perfect. So let's go to the third test. This time our re-entry point will be in front of the Kerbal and the periapsis will be 90 degrees to it, so we have to get more gravity assist on the re-entry point. So let's do the maneuver, let's correct everything to perfect numbers and time warp closer to the re-entry effects. So here we are, ditching our upper stage or lower stage, however you want to call it, and let's see how the re-entry goes this time. We are at 67, 66 kilometers. We are piling up the Gs, 3.5, 3.6, and the G meter is going down for now. And our apoapsis is falling into the atmosphere and into the planet below. So in the end, we will definitely get down. Our G meter is rising again, but not very fast. At the moment we're at 2.5 Gs and we're bleeding off our speed with 5.5 kilometers left. So the Gs are going up, speed is going down. 6 Gs, 7 Gs, 8 Gs, and at 8.4 Gs we actually stop with the deceleration and everything is perfect. Time to go for the next test. This time our re-entry point will be behind the planet Kerbal and our periapsis of course 90 degrees to that point. Apparently we should increase our velocity when we re-enter, and I'm not exactly sure how it will help us, but I assume that we shall have a little bit shallower re-entry and have a little bit less problem with Gs. So let's see how it goes. We are re-entering at 90, 85, 80 kilometers. Our Gs are rising, but again not very fast. We are approaching 2.5 Gs, which is perfectly normal, and actually go a bit higher to almost 4 Gs, 4.1, at which point the G meter almost stops but then starts going up again, as well actually already lost our apoapsis and we are going down. So we are approaching 6 Gs, 7 Gs, 8 Gs, 9 Gs, that is a bit scary, 9.5, and then it starts going down, meaning that Jebediah Kerbal survives and everything is perfect. So in the end, it looks like at such low altitudes gravity doesn't really affect our re-entry, but it looks like that re-entering either directly behind or in front of the Kerbal leads to a little bit more stable and gentle re-entries, with re-entry behind Kerbal being the most gentle one. And as we completed our scientific program, let's have a little bit of fun. This is a craft returning from Minmus, which is actually Uranus in the real solar system. So we are going to encounter Kerbal at very elliptic trajectory, and we're going to see how gravity assists are actually affecting us at such high speeds and high distances. So our first re-entry will be behind the Kerbal with the gravity assist that will impart speed on our ship. So let's make our periapsis approximately 70 kilometers, because anything lower than that will probably destroy our ship with gravity forces. So something like that. And let's time warp into the atmosphere. There is our trajectory going on escape velocity from Kerbal system, meaning that gravity assist gave us a lot of additional speed. And let's see how it goes with the re-entry. Apparently we only reached 8.8 Gs before we reached our periapsis, and it didn't really affect our trajectory. So let's try again, but this time let's re-enter in front of the Kerbal, meaning that we will get reverse gravity assist and hopefully maybe even land. But I wouldn't bet on that, because the speed of re-entry is very, very big. So let's try it again. Making sure that our orbit is in front of the Kerbal. Just like that. And let's time warp to the sphere of influence of Kerbal and into the atmosphere. First, of course, we're going to do our maneuver, derp, and now, after the maneuver is done, we are going to time warp, get into the sphere of influence of Kerbal, and change our periapsis to the same 70 kilometers. Again, I'm pretty much sure that this one is also not going to return home, but we're doing it for fun, and we're not doing it for the profit, or for re-entry and return of Jebediah Kerman. Immediately we start seeing re-entry effects, and we are definitely leaving the sphere of influence of Kerbal again. This time we got to 9.5 Gs, meaning, as normal as it sounds, the planet provides 1 G of gravity. If we were at some other planet, for example Joule, we would have more acceleration or deceleration due to the higher gravity of this body, but the Kerbal itself cannot provide us with more acceleration or deceleration. And so we come to the end of this episode. I hope you liked this testing. Please note that I do not pretend to know anything about astrophysics and everything tied to that. So it is entirely possible that I was talking out of my arse the whole time. Thank you all for watching. Remember to like, dislike and comment this video in the section below. My name is Darlock, and I will see you next time. Goodbye!